Okay, good day. We are going to have another problem on graphical method. So in this, we have four vectors here. Okay, so for the first vector, it starts with a vector that does not lie on the x-axis or the y-axis. So we have to use an imaginary Cartesian plane for that. But before we do the drawing, we have to consider and we have to choose an appropriate scale. So for this, let's have 10 millimeters equals 1 meter, okay? And so we do the scaling down because from meters, we're going to scale it down to millimeters so that we can use our ruler. Okay, so D1 shortcut, no? So 4.00 meters upon scaling down using this, you get 40 millimeters. The direction remains the same at 40 degrees east of north. So D2 becomes 20 millimeters, D3 becomes 52 millimeters, and D4 becomes 65 millimeters. Okay, so these are the scaled down value magnitude of the different vectors. Now we try to estimate where this is headed. So it says here D1 is heading 40 degrees. Okay, remember our orientation would be north, south, and this is west, and this is east. Okay, so 40 meters at 40 degrees east of north. So where is east of north? Okay, so it should go in this direction. And then east to the right. Okay, and then south of west, okay, based on this, ba siya. And then south, it would go down like this. Okay, and then we connect. Somehow our vector would look like this, okay, when you join them head to tail. Okay, so D1, D2, D3, D4. So let's start on the right, okay, lower right side, because we know that it's going to head up. Okay, so we choose a convenient starting point. Okay, let's choose this point here. Okay, and then we draw an imaginary Cartesian plane, this being your x-axis and this being your y-axis. Okay, so um, 40 degrees east of north. Now it says here of north, so we have to put our protractor in a vertical position. Okay, so east of north is in the first quadrant. So where is 40 degrees? It opens from the north, so it should be here. Okay, yeah, this is 40 degrees. This will be our guide, this point here. And then we measure for 40 millimeters. Okay, we measure 40 millimeters. Okay, so this gives us 40 millimeters. And then 2 meters, 20 millimeters east, okay, 20 millimeters east, we draw the figure to the right. Okay, so heading to the right, we don't have to draw an imaginary Cartesian plane because this one lies on the x-axis. Okay, so this is 20 millimeters. Okay, let's name this as D1. This is D2. Now for the third vector, let's see. It says here 52 millimeters at 30 degrees south of west. Okay, so south of west. Again, it's a vector that doesn't lie on the x-axis or y-axis, so we have to draw an imaginary Cartesian plane. Okay, so all right. Now we get our protractor. And then it says here 30 degrees south of west, opening from the west, heading towards south. So we put the protractor in a horizontal position. Then look at where 30 degrees is dito sa red line. Okay, so this will be our guide. Then we measure 52 millimeters. Okay, 52 millimeters. Almost went back to the starting point. Okay, so let that be D3. And then it says here 6.5 meters south. The equivalent now is 65 millimeters south. Okay, so 65 millimeters south. We don't have to draw an imaginary Cartesian plane. And this is 65 millimeters south. Ayan. Now from the starting point up to here, D4, okay, that would be also be your resultant. Okay, so we measure this. Also 65. So our D sub R is equal to 65 millimeters. Then we put this back into the meters. We scale back. So D sub R times, okay, this is 10 millimeters, equivalent to 1 meter. Okay, so this will be 6.5 meters. Okay, our magnitude is 6.5 meters. All right. Now the direction is almost south. So we can just say south. Okay. So, and you don't have to compute using arctan anymore. So theta, so the direction is south. Okay. This would be our final answer. The resultant magnitude is 6.5 meters. The direction is southwards. Okay. And that's it. Let's have another example later on. Thank you very much.